Thank you for this nice introduction, and thank you, ladies and gentlemen, for giving me the opportunity to tell you a little bit about SABIC and one of the solutions which I would like to focus on today in this presentation in the light of the theme of today, which is lightweight applications. Please see how it works. What I would like to do today is to first give you, before I go into my example, give you a small introduction with regard to all the different solutions which we have in the exterior in the lightweight plastics. Then followed, I would like to go into the vision which we have on our tailgate solution, and I hope you already saw a little bit which we have there on display on our booth. Followed by going into the concept, how we have developed that, with some examples on the performance, and then I'll close it off with the conclusion. Good. We've heard already a lot of times the different themes which around the needs which we see in the industry, and of course also SABIC plays its role with regard to offering solutions which give answers to all these different needs with regard to having a more fuel-efficient car, having a car which is more environmental friendly. Of course, also safety is an area where we are heavily engaged. The car has to look nice, so it has the design is enabling with our plastics is what we offer, of course. The branding, and not to forget also the performance which you need for that. If you look to the exteriors and the solutions which we have at the moment on the marketplace, it's a wealth of different applications. And you see them all around the car. And I'm going not into detail, but what I would like to do is at least, okay, the themes where we are focusing on in order to give value to our customers with regard to all these different topics. Lightweight, already a lot been discussed today, but also the other things which we are delivering all kind of different solutions to the industry in order to answer these different needs. Good. I don't need to talk about this a lot. It's already been said a couple of times. So I only can confirm that also we have recognized that weight is something where the automotive industry is focusing on. So that's where we are playing in. And weight is one of the important factors to save energy. And that's what the OEMs also try to telling us very often. It's not only weight, it's also other areas where you guys have tried to help us. Also, I'm happy that I saw confirmation of our own calculation which we made, where we were saying the 750 liters of petrol savings you can have over the lifetime of a car. That's exactly in line what we see. And this is, if you talk about lightweight solutions or applications, then there is the total portfolio which we are positioning now specifically answer that. These are the technologies which are commercial and are available at the moment, but also, of course, we are working and developing new technologies for the future. Okay, just to give you an example what the impact is of lightweighting, it's been said already on one car, but the way I try to look at it is if I would take this example, for instance, which is a normal GTX fender, I could reach a weight out of approximately 3 kilograms on a car. If I would imagine that every car in Europe would have this kind of technology, then you could save up to 420 million liters per year, which equals almost 1.2 million metric tons of CO2. If I would even look to another application area, which is, for instance, an area where we are looking at as well a lot, is this plastic glazing. And you can achieve a weight out of approximately 18 kilograms, which even gives you a gigantic kind of saving over a year. So this is just another way I would like you to show you today. Good, for today, the tailgate. And like I said already, I hope you already had a look to our booth. I will go a little bit over there, what we have done there. The main theme which we had for this application is to minimize the weight and to offer the styling differentiation which where the OEM is looking for through a maximization of the design flexibility which you have with plastics. So tailgate is not something new. Tailgates, plastic tailgates is something which we see already for a couple of years. But the only thing which we see too much happening, unfortunately, that is just a change of replacement of a traditional material into plastic. And with that, you immediately give yourself all kind of limitations with regard to how you can optimize it for a plastic. Sometimes even with the risk that you don't achieve the weight reduction or the performance or even the cost targets which you had in the beginning. So our view was a little bit different in this respect. We said, okay, we want to optimize this design in such a way through, of course, all the design and engineering support which we offer usually in our day-to-day job with the help of plastics in order to come to this the significant weight reduction through maximizing the and using the design freedom which you have with plastics. In the beginning of the project, we set ourselves a couple of targets. We said we want to at least be 30% lighter than a conventional tailgate. It has to be the same with regard to performance. From a cost perspective, we said, okay, let's target to come to an even with, let's say, approximately a volume of 100,000 units per year. We said we want to focus in this one for an offline tailgate, where on the inside we want to use the structure as the Class A service, so no additional components being added onto the tailgate. Also, we wanted to integrate a hinge into the inner structure. Wanted to put as much as possible functionality and design into our backlight. And the exterior part, we said, okay, we want to have that mechanically fixed in order to offer also a repairability and serviceability later on when the car's on the road. And also that gives then, at the same time, a flexibility with regard to the painting options which you can have, because the part which the blue part, which is the painted part, is the only part which differentiates from the rest of the tailgate. Good, now let's have a look what we have done. So we started off first with sketching we looked around what we see on shows and what we, for instance, think, okay, this is the direction the automotive industry is thinking, and we start sketching, and we came up finally with this design. We said, okay, let's focus on this design and try to optimize this towards plastic solution. And this was the end result. If you turn it around and have a look to it, you see, and we focus on certain areas, you see that we try to put already a lot of function or styling integration into one part. For instance, if we look to the top, you see that we put it there, the spoiler in the backlight. So we have a polycarbonate backlight which fully molded, and with the spoiler is integrated in there. At the same time, we have here on the sides, we have an airflow guys, typically in applications which you see now very often glued onto the window for aerodynamic needs. Also had some additional design features here on top. Well, since we have this transparent Lexan polycarbonate, and which is also used for lamp applications, why not integrating that directly into the tailgate? So we said we want to have also the lighting directly integrated into the backlight. And this is a little bit how that could look like if you see that from the rear in the dark, how these different functions are there. And we did a lot of work in order also to fulfill all these different requirements which are around there with regard to distances and angles, etc. So this is the way the lighting could look with all these different functions which you need to have. And if you look at then from the total rear view from the back, you see we even put the rear or the logo into a lighting. If you talk about lighting, we see it actually already on the road that the OEMs are struggling. You have very sharp edges, eyebrows, shapes which you cannot think of when in the traditional material, or at least not with the gaps and flushes which with the OEMs are looking for. So we really put it to the extreme, really wrap around the car in order to really take the extreme of what you can do with plastic. Good, that's it with regard to the concept. Now let's see how the whole thing is being built. And we take it apart and we're going to build it together again. The first part where we start with is our StarMax PP LFT material, which we are going to injection mold with the inserts already in there. If you look to the part here, for instance, in the top area, you see that we have a lot of structure already being put in here in order to get the torsional stiffness which you need there. Then we have here the D-pillar, which is typically an area which has to give you the bending stiffness in order to fulfill these load cases which you're having. We put a lot of structure here under there, but also we added here an additional part which we call the torsion box. Initially we wanted to do that through ribbing, but we saw through this box kind of shape that you even can reach more weight out than you can do with traditional. For the US and for the Pacific, we need a crash to fulfill crash requirements. So what we did is we added a crash cable, which is connecting actually the hinge to the lock area in order to maintain it onto the car in case of a crash situation. Then we apply in green the 2 ropes of glue, and we're going to have a look to our fully surface injection molded polycarbonate, which is over molded with a second shot in order to get the blackout, but also all the functionality which you want to put into this glazing part. Then these 2 parts are being glued together, and with that you already have created here a room which is our housing, our lamp housing. So the only thing what you need to do now is to put very lightweight lighting solutions which you can put in there. With that we even achieved an extra 1.5 kilogram weight reduction pure on the lighting by doing this. The light is directly fixed with a couple of screws onto the glazing part, and then we have here the last unit which is also being moved in there. In a normal production process, you would do it in a different way, but I just want to show that also serviceability is something where we were thinking about. Attachment of the wiper motor and attachment of the lock. And then we go to have a look to our exterior part. The exterior part which is either on or offline painted. We put the third brake light on there, also the license plate light and the door handle. Then we have our sealing in between in order to ensure water ingress. And you see here snaps, which are snapping into the rigid area already into the tailgate. And with the U-shape, it's really locked onto this part. And the only thing we need to do then is secure it with additional screw here to the body. 2 additional screws for the hand grip, and then we close it off, and the tailgate is almost ready. The only thing which and by the way, you have here an impression of the surface quality which we can achieve with our material. Then we have the bump stops being installed into the inserts which are there, the gas strut fixing and the gas struts, and then the last thing which is coming here on the top is the hinge pin going through the crash cable, connecting the hinge to the part. Last thing is the wiper, and the tailgate is ready. Good. Weight. We have to imagine this is a very big tailgate. We're talking approximately something like 1.70 meters width with a height of approximately 1.20 meters. And we did quite a number of calculations and came up with this weight reduction. So in other words, we brought it back from, for traditional materials, it would be somewhere above 40 kilograms to 30 kilograms. So a little bit on the components. The components are the different materials which we use for the different applications. So we have the glazing here with polycarbonate Lexan, a second shot material with the PC-ABS mineral filled material. Then we have here for the inner structure for both parts a glass fiber reinforced Stamax PP and the exterior parts. Then a few words on calculations which we did, because we did not only do that conceptual, we did the engineering and the styling, but also we did a lot of predictive engineering. And one of the things which we did, for instance, was calculations in order to ensure that the partners were fulfilling all these requirements. So we did a number of iterations on the different load cases, and actually what we did already is we took it up to 80 degrees C in order to make sure that we will fulfilling these requirements already at that temperature. And here you see a snapshot of all these different load cases which we took into account. Next to that, we also did all kind of other analysis. I'm not going to talk about that. I can do that on a later stage. Parallel to that, we also looked, of course, can we make all these parts? So what you see here is a mold flow study of our backlight The first shot here is on the Lexan with an sequential injection compression molding process, with a second shot with a sequential injection molding for the overmolded part. And then the last sheet I want to share with you is this one, which is on predictive engineering, which we did for the inner structure. For the inner structure with the glass fiber, it's very important that you not only can make it, but also that the dimension is correct. So we went through an optimization for the all the gating points, and in order to achieve that the part is dimensionally correct. And we even took it to a next step, that we took that result of that calculation back into the structural analysis to look again if the results are okay, yes or no. I'm looking to the organization. I think I have to stop here with my presentation. Thank you for your attention, and if there are any questions, then we can discuss that later on our booth. And thank you.